Hello, good people of the south, of the north, of the east, of everywhere in the world. Hopefully, there are good people that want to actually do some grade 9, mathematics this morning. All the people that want to do some grade 9 mathematics this morning, put your hands up, Yeah, because I'm here for you, I'm here for all those peeps that want to do some grade 9 mathematics this morning. If you are down with some grade 9 maths this beautiful morning, if you are in grade 9, put your hands up there in the comment section. You can put your hands up if you're in grade 9. Let's get some grade 9 maths going, man. It's been a while, it's been a minute. Grade 9s. Lack of focus on you. Just need to restore that focus back on you so that we can get some maths grade 9 going. We are still, with my grade 9s, we are still doing algebraic expressions, right? Algebraic expressions. All right. For those who may be joining in for the first time, guys, I have a YouTube channel. The YouTube channel is called Maths is a Game. You can go to the YouTube channel Maths is a Game. All right. Please, you can check out the previous live sessions that I've done with the grade 9s. I'm going to pick up with the grade 9s from where I left off, which was like literally a few weeks ago. So it's been a while, right? But I've actually adorned my YouTube channel with all the sessions, the live sessions that we've done. Thank you so much. Who's this amazing young lady here who's just Tabs and Tabs. Thank you so much, Tabs and Tabs, for the heart me. Really appreciate. So guys, I just want to pick up from where we left off, right? Because looking at grade 9 algebraic expressions, we were looking at grade 8 revision. We looked at grade 8 revision. We actually stayed there for quite some time, and we picked up what it was that was important for us to learn. Oh, Tabs on Tabs. Tabs. Yeah, no, you just want to make me smile this morning. Thank you so much. Yo. Guys, I'm sorry if like I'm... Yeah, you know, the thing is, these rare occasions of gifts, and they are very rare. So when I do get them, I'm very appreciative. Let us send the call to all. Thank you so much, Tabs and Tabs. Really appreciate it. Okay, so grade 9, guys. Grade 9. Please, grade 9. Okay. After this grade 9 live session, I'll do a grade 10 session on Euclidean geometry. Okay. So grade 9, I'm going to probably spend just a good hour. We are literally going to take from 11:15 up until 12:15. That will be grade 9. After the grade 9 session, we'll do a grade 10 session on Euclidean geometry. Specifically, we'll be looking at quadrilaterals, quadrilaterals for grade 10. So that will be grade 9 now. Now we'll be doing grade 9 algebraic expressions, and we'll be looking specifically under algebraic expressions. We are going to look at products of binomials. In other words, multiplication of binomials. Multiplication of binomials. Okay, yeah, that's what we'll be looking at. Yeah, thank you so much, Tabs and Tabs. Really appreciate it's encouragement. Many times I think people think that people that go live and they do live lessons for free, because I'm not asking anyone. No one who joins these sessions, I'm asking them to pay something so that they can be part of the session. No, everybody is welcome to join for free. So I really appreciate it, Tabs, more so the words of encouragement, because if you're saying I'm doing a great job, then I really appreciate it. This is coming from a genuine place in my heart when it comes to these lives. I'm doing them because, honestly speaking, when I hear certain learners tell me, they send me inboxes, they'll say, "Sir, we don't have a teacher in our class, and we've been without a maths teacher for a while." That worries me a lot, right? So there's sort of like a element of sense of responsibility, because I know what I know, and so I'd want to give, you know, to others what I know, the knowledge that I have, impart it to others so that they can have the opportunity of doing very well in a subject that is very fun, if you ask me. Okay. Maths is a game, literally, guys. When I say maths is a game, you know, any game that you play, you know, it's fun, right? So maths is a game. It literally is, you know. And I think once the learner, it hits them that, yo, this thing is actually a game, then they play it and they enjoy it and they have fun with it. And then the byproduct of all of that are good marks, okay? So I hope that makes sense. So guys, like I said, I'll be doing this grade 9 session. I'll be pushing it up until 12:15. Grade 9 algebraic expressions, multiplication of binomials, we'll look at that, and then I will transition grade 10, right? After this session, I'll take up a grade 10 session. We'll be doing Euclidean geometry with the grade 10s. So let's look at multiplication of binomials. We'll start very basic and then we'll move out to a bit more complex things. So first and foremost, I just want us to look at this law. This law has been a very pivotal law, this law called the distributive law. When you know, when they say the word to distribute means to actually share something out, you know, to share something out. So for instance, you think about what you might call distribute. It's when you share out something, a particular thing, you share it out amongst other people, right? So here's this concept. Okay, here you have an A, you have brackets here, you have a B plus C. So first and foremost, we want to identify in this expression how many terms we have. So the thing is, when it comes to knowing how many terms there are, we need to realize a few things, and this is something that I shared in my previous lessons, and that is one term, okay? A particular term is made up of a number combined with a variable, or it can be a number alone, okay? So in this case, we have a variable. In other words, a letter of the alphabet. A variable is a letter of the alphabet. We have the letter A, and then in brackets, we have B plus C. Brackets in and of themselves mean something in mathematics. Brackets mean multiply. So since brackets mean multiply, the relationship that exists between this A and this B plus C inside this bracket is a relationship of multiplication, okay? So with that said, we would say, if I would ask how many terms do we have in this expression, you would simply tell me there is one term in this expression. Why? Because this A, brackets B plus C, A and the bracket combines together, and then we have one term. Brackets in and of themselves make something become one term. Okay, so B plus C becomes one term. Why? Because brackets do this amazing thing. Brackets just make something become one. Okay, so for instance, if I was to ask you how many terms do we have in this expression B plus C, you would say to me we have two terms. Why? Because you know that a plus and a minus sign separates terms. Okay, so B plus C, if I asked how many terms there were, you would tell me there are two terms. Okay, beautifully said. You would say that. Why? Because you know that a plus and a minus sign will separate terms. But if I say to you B plus C in brackets and I asked you how many terms are in this expression, then you would say to me, sir, there is one term for this expression. Why? Because of the brackets. So brackets, sort of like, they are the cause for unity, you know. They bring things together. They make them to become one. Brackets are the cause for unity. Brackets are the cause for unity. We become one, all right? Inside this bracket, okay, we have two terms, okay? There are two terms inside the bracket, but because of this bracket, we would say that this expression is one term. That's simply because of the bracket, okay? So just a quick announcement, grade 9s, I'm having a session with grade 9s now from 11:15 when it started up until 12:15. Then after that, I'll have a grade 10 session on what? On Euclidean geometry. Euclidean geometry for grade 10s, okay, because I'm picking up from where I left off with the grade 10 since I last had a session with them. And then after that, if there is time, guys, I will do a session with the grade 11s immediately after the grade 10 session. But that will wholly, completely depend on my time, okay? So that is the lineup. Then later on in the evening at 11:30, my grade 12s, I'm having a session with them on calculus, differential calculus. We started off with the grade 12s with deriving using first principles, and then we looked at the differential rules, okay? So we'll look at that later on in the evening at literally 10:30. 10:30, my grade 12s, like I said. So that should be everyone excepting the grade 8s, right? So we are busy now with the grade 9s, okay? Right, so like I was saying, guys, B plus C, how many terms? One term. Why? Because of the bracket. Brackets cause unity. B plus C alone without the brackets, that is clearly two terms. So if we look at this expression is one term. One, all right? But we need to be vigilant of the fact that even though this is one term, if we look at the various components of this term, there's an A which has next to it a bracket, and remember the A and the bracket, they have a relationship of what? Of multiply. Why? Because brackets, guys, mean multiplication. So the minute you have something outside a bracket, you know its relationship with the bracket is multiply. I hope that makes sense. So what we then do, okay, when we are simplifying, is we apply something called the distributive law. The distributive law applies whenever we have a bracket and we have something external to the bracket. So what we simply do is we take the A, we distribute it to the B, and when we apply this, and I'm going to call it for short, distributive law, DL, when we apply the DL, we consider, take note of S, N, L as we go along. In other words, we must consider the sign, we must consider the number, and we must consider the letter. Those who have been in my live sessions have seen how obsessed I am with S and L. What's even worse, those who are my learners at school know how obsessed I am with S and L. It's not even funny. Like, it's my obsession with S and L is beyond anything that you can ever imagine. In mathematics, you must know that something has gone terribly wrong if I do not, in some session or a lesson, try to rope in S and L, because that's how important S and L is. Sign, number, letter. So when we apply the distributive law, we consider our sign multiplication, our number multiplication, and our letter multiplication. Okay, and remember, whenever we are dealing with the letter, we must remember exponential laws. You know, the fact that when you are multiplying bases with the same exponents with the same bases, you know, you must keep the base and you must add the exponent. Very important thing to consider when you are talking about letters. Different letters, when they are multiplied together, they simply get combined. All right, you just combine them. It's like glue that sticks together, right? Very importantly. Also, if you find that you are multiplying something and let's say there's a similar letter in the denominator, remember that there, where that is concerned, division of same base letters means that what do we do? Obviously, guys, what do we do? There's two things that we can consider. We can either cancel, right? There are two of the A's at the top. There's one A. You can cancel there, right? And you have one A at the top, whereas at the bottom, obviously, A divided by A gives you 1. Okay, so that's very important. Okay, very, very, very critical and important, that idea there. So that basically leaves you with an A there at the top. A times 1, obviously, it leaves you with an answer of A. So those are things that we need to consider, you know, when we are dealing with the letters. With the numbers, guys, your calculator is there. You can simply multiply the numbers. Then with the signs, let's remember, guys, that a negative times a negative is a positive, and a positive times a positive is a positive. Same signs multiplied give us a positive, but then different signs multiplied give us a negative. Okay, if S and L is known very well, what we do with signs when we multiply, what we do with numbers when we multiply, what we do with letters when we multiply, then this here, asuka, easy, capizi, capush, all right? Easy, capizi, capush. All right. So when you apply the distributive law, let's distribute A times B. So you look at the A. Is it what? What sign? Positive and a positive. Because that's where we start when we distribute. We look at the sign. So positive times a positive is a positive answer. Now, the positive sign, guys, the positive sign can remain invisible. It doesn't have to be visible. The positive sign, invisible as it is, has its presence there. Talks about other things that are invisible in life, but they are there. The positive sign must be invisible. It doesn't have to be written, all right? Especially if it is a first term and it's standing alone, okay? Where the positive sign has to be visible is when the positive sign is in between two terms. Then that positive sign has to be visible. So it's invisible if it's a first term. And I repeat, if the positive sign is a first term, it is invisible. But if the positive sign is in between terms, then it must be made visible. It must be made visible. I repeat, if the positive sign is in between terms, it must be made visible. But if it is for the first term, that positive sign can remain invisible. That means it is there, and it's fine that it is there. Okay, so let's go, guys. Look at this. The positive times a positive is a positive. Got it. The 1, there's an invisible 1 there, and there's an invisible 1 there. 1 times 1 is 1. Okay. This also goes for 1. 1 is also invisible. Remember now, there's a rule that applies for 1. 1 is also invisible, but it is invisible under these conditions. If there is a variable, it can remain invisible. But if there is no variable and the 1 is alone, then it must appear. Okay, so 1 is also invisible if it is accompanied or combined to a variable. Very, very important to note that. Okay, so let's go here. So like I said, positive times a positive is positive. 1 times 1 is 1. So the sign and the number have been taken care of. Now I go on to the letter. What's A times B? The A and the B are different letters. So what do? We combine those letters together. The answer is AB. So for our first term, after distributing A to the first term, I get AB. Then I do the same thing. I distribute AB to positive C. Again, I consider distributive law, which means I'm going to multiply, guys. I'm going to multiply because remember, brackets mean multiply. When I apply the distributive law, I am multiplying. So once again, what do? I say a positive times a positive. What do I get? A positive. You see the positive sign because it's in between the terms. Okay, because the positive sign is in between the terms, it must be made to be visible. We must see it. So there it is. Then 1 times 1, there's a coefficient of 1 before the C. What's 1 times 1? It's 1. Okay, it can remain invisible. Why? Because there's a variable there. Okay, and then what's A times C? That is AC. Okay, letter done. Then we look at the two terms and then we must ask, are they like terms? Because remember, in mathematics, like terms we can add or subtract. But unlike terms cannot be added or subtracted. Like terms can be added or subtracted, but unlike terms cannot be added or subtracted. So with like terms, what are like terms? Like terms are variables that have the same base and the same exponent. So if you look at AB, all right, there's an A here for this term. There's an A for that term. There's a B for this term. There's a C for this term. Are these like terms? No, absolutely not. What do we know about unlike terms? unlike terms cannot be added or subtracted. So we leave the answer as AB plus AC. Done, finished, dusted. Grade 9s, listen to me and listen to me well. Everything that comes after this is simply your application of the distributive law. Application of when you distribute, making sure that the sign is taken into account, the number is taken into account, the letter is taken into account. And guys, it's simple as that. As simple as that. We add like terms, we cannot add unlike terms, right? So now we are going to now dive into, this is the law, okay? You've seen how it is applied. It is always applied where there's a monomial, and inside the bracket there's a binomial. We apply the distributive law. So now we are going to go ahead and look at the multiplication of binomials. All right, are you ready for multiplication of binomials? Are you ready? Are you ready? Are you ready? All right, here we are. Let's look at a few examples. Actually, we're going to look at 3 examples, and then after we look at 3 examples, I'm going to give you some of your own. I'm going to invite some people up who can help me out in answering the questions, and yeah, we're just going to take it one step at a time, and we'll see where we end. So for our first question, we have x plus 3 into x plus 4. Now, if you look at this, guys, we have a bracket there and a bracket there. So if I ask you this question, how many terms do we have in this expression? What would you say? How many terms in the expression? So your beautiful answers in the comment section are, how many terms do we have in the expression? Okay, I see Kia, what you are saying there. I see Severe, what you are saying there. And I'm going to give an opportunity for people to answer, and then I'm going to drop the indomitable, undeniable truth that pertains to these terms and how many they are. All right. And guys, you are giving answers based on your knowledge and your understanding of expressions. How important it is that your conceptual knowledge and understanding of expressions is solid, because when it is, then you will tell me the truth. You will not lie to me, okay? So some of you in the comment section are lying to me, and I'm sorry to say that, but you are lying to me, and it's based on the fact that we lack that solid understanding. Good people, if I ask you how many terms there are in this expression, all honest people will say, sir, there is 1 term in the expression. Now, I need all those people that said 2, 3, actually, that said 2. I need you to ask me the question that you want to ask me in the comment section, because I'm sure you are like, huh? How can this guy say there's 1 term? How can it be? It cannot be. Yeah, so I want those people to ask what they want to ask. For instance, Mkwebu there and later, do you want to ask your question? What do you want to ask? Because you said 2 terms, but I'm sure you're like, how can it be? How can this guy profess that there's 1 term? How? All right. So Sia for Life there in the comment section says multiplication combines terms. Guys, remember this. Bracket, okay? This bracket and this bracket, okay? These brackets, for instance, how many terms do we say this is? If we put a bracket like this, if I asked you x plus 3 in brackets, how many terms are there here? Okay. How many terms there are? No, it's good. And I'm glad you are here to learn. You've got the right heart, Elita. And I'm not trying to make you guys feel terrible or anything like that. Please receive my nuances and my corrections, sort of like the way I tend to say things. Please receive them with a good heart. Don't take them personally. Don't take it personal, right? So if I say x plus 3 and I put it in brackets, I ask you how many terms there are here. Then we all know that there is 1 term here. Why do we say 1 term? It's because of the bracket. Sir, you said earlier on that a bracket will combine and make this 1 term. Guys, this is 1 term. Please, please, please. Because of the bracket around x plus 3, this is 1 term. Why? The bracket makes it so. But if I wrote x plus 3 like this without the bracket, okay, then we would say this is 2 terms. So please, guys, in grade 8 last year already, you guys learned that when there's a bracket around, however many terms, you could have this, for crying out loud, x squared plus 3x minus 5 plus 7y squared. Guys, the minute I do this, I put brackets around. Do you know how many terms there are here? The minute, if I ask you in this expression, how many terms? Then you would say 1 term. Why? Because of the bracket. Okay? That's why. That is why. All right? 1 term. 1. Okay? So the bracket makes it 1 term. Now let's go back. Let's go back. I hope you've gotten the principle and the concept now. X plus 3 into x plus 4. I'm asking again, how many terms in the expression? How many terms in the expression? And my grade 9s, if you can just get this once and for all, this thing about, if you can get this once and for all and don't let it go after you have gotten it, then you will be fine. You'll be fine in so many things in mathematics, I promise you. So x plus 3 into x plus 4, I ask you, how many terms are in this expression? Guys, listen to me and listen to me very well. You know that x plus 3, right, in brackets means that this here alone, if you look at it alone, is 1 term. Are we together? Then let's leave this bracket. Let's go to this one. Let's pretend this one is not here. Let's look at this alone. X plus 4. Now you also know that this alone is 1 term. Are we together? But these 2 brackets are what? Are combined together. Meaning, in maths, we know brackets have a meaning. Brackets mean multiply. That's what brackets mean in maths. Brackets mean multiply. Are we together? So, because of the fact that, yes, we have 1 term, but remember, it's 1 term because it's in a bracket. There's another term, it's in a bracket. But these together are what? They are further combined by what? A bracket. What do brackets mean? Multiply. What does multiply do to 2 things? Multiply. What does multiply do? It combines. So that therefore means that this x plus 3 in brackets and this x plus 4 in brackets combined together with the multiplied sign make this thing become what? 1 term. 1 term. And that is because of what? Brackets mean multiply. What does multiplication do? It combines. Yes, Julia. Yes, Julia's. Okay. This is 1 term. Please, good people. Brackets combine because brackets mean multiply. Okay. So the 2 operations that combine terms, multiply and divide, combine terms. Whereas addition and subtraction, what does addition and subtraction do? Okay, you see now I'm finding myself having to teach these basics. Addition and subtraction do what? They separate terms. Okay? So who is involved in the unity of South Africa and the nation? It's multiply and divide. We are one. Simunye, But who's involved in the separation and the divorce of couples everywhere across the world? Addition and subtraction. Okay? Right? And remember, multiply. Brackets mean multiply. You see these things, guys? Please, can we get this once and for all? I beg you guys. All right? Okay, now I'm back to my example because you guys have literally, you've made me go in it, These are things that I explained in earlier videos. You see? So x plus 3 into x plus 4. What are we supposed to do here? We want to simplify x plus 3 into x plus 4. So I asked, and I'm asking again one more time. Let's see if my people are listening. How many terms are in this expression? Do you want to populate my comment section with the right answer this time round? How many terms are in this expression? Oh, look at my people. They are learning. Woo! 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 Yeah, that's what I'm talking about, good people. All right, please. IOT. IOT. No, YOT. I'm going to take you and I am going to put you on the cross as well. YOT. No. Okay, so x plus 3 into x plus 4 is one term. Okay, so it's very important, that first question. How many terms? There are two terms. Now, when we want to simplify, guys, we apply the distributive law. Ne? Now, please be with me for a moment. How is it that we are saying we apply distributive law? Smartly, so you are going to have to watch the video when I post it, because I'm not going to re-explain this again. I've been explaining it, okay? But the people in the comment section are more than welcome to type and help Smangaliso there in the comment section. So we are going to apply the distributive law. So x, we are going to distribute x to x. Are you with me? This same x, we are going to distribute again to positive 4. Do you see that we are applying the distributive law? We are doing it. We are applying the distributive law. And remember, when you apply the distributive law, we have to use what? SNL. Now, this distribution, remember, at the end of the day, this is the law that we are applying. This law, as we apply it, gives rise to what we say is FOIL, right? X must be distributed fully to the two terms inside this bracket. Then 3 must also be distributed fully to the two terms inside the bracket. Are we together? Hey, I hope we are together here. Okay, it's x to x, x to positive 4, then 3 to x, 3 to positive 4. Remember, everyone here in this bracket needs to be distributed first equally to each term. So x needs to first get its fair share. We distribute x to x, we distribute x to positive 4. Then after we are done, we come to positive 3, we do the same thing. We distribute 3 to x, we distribute 3 to positive 4. And remember, guys, that when we are doing the distributive law, okay, this FOIL, you must be asking yourself, what does that even mean? So this is me saying we must multiply. F stands for first terms. F stands for our first terms inside the bracket. X and x are our first terms inside the bracket. What must we do? Multiply them. Are we together? So we take this x and this x. It's like saying x times x. The x is positive. This x is positive. That's our first terms. Are we together? Then O. What does O mean? It means we take our outer terms inside the bracket. So our outer terms, x is out on this side, 4 is out on this side. Are we together? X is out on this side, 4 is out on this side. But if you're understanding the distributive law, then you know that x needs to be distributed to the first term, x needs to then be distributed to the second term. Okay? Then I, so that's x times 4. And please take note, x is positive, 4 is positive. Then I stands for inner. Inner what? The inner terms. So now we are coming to the 3, which is positive, and we are multiplying it to the x, which is positive. Are we together? Then the last one, L, stands for our last terms in the bracket. In this bracket, inside this bracket, positive 3 is your last term, and in this bracket, positive 4 is your last term. So that's like saying positive 3 times positive 4. So that's what FOIL actually stands for. Okay, this is just us applying the distributive law, but we use this acronym to capture what it is we are multiplying. Are we together? Then, as we multiply, let us not forget the glorious S and L. Meaning, when we multiply, let us consider the sign, consider the number, consider the letter. Okay, so I've just written all of this down so that you guys can see what it is that I'm doing. All right, but as we answer the question, we simply do the multiplication and say, what's x times x? So that x times x, I know that when I'm multiplying same bases, okay, so positive times a positive is positive. 1 times 1 for the number is 1. X times x gives me x to the power. Remember, this base has an exponent 1 that you don't see. This base also has an exponent 1 that you don't see. So when you are multiplying same bases, we keep the base and we add the exponent. So that gives me x squared. Okay, so there we have it, x squared. Then we move on. X times 4, x times positive 4. A positive times a positive will give me a positive. So of course, when the sign of plus is in between, we write it down. Okay, then what's 1 times 4? That gives us 4. Then the x, that just gets combined with the number. We are done with f and o. We've got an x squared, we've got an 4x, and there we have it as an expression written underneath our question. X squared plus 4x, that's distributing x to x and distributing x to positive 4. Now let's move on here. A positive times another positive gives us a positive. 3 times the coefficient of x is 1 gives us 3, and then the x next door to the 3 combined. Then lastly, positive 3 times positive 4. Positive times a positive is a positive. 3 times 4 is 12. There's no letters, so that's perfectly fine. Now remember, after you are done doing FOIL, then you must check, are there like terms in the expression? Because I know with like terms, I will add or subtract like terms. Okay, we can add or subtract like terms. But with unlike terms, we cannot. So are there like terms inside, in this expression? There are now 1, 2, 3, 4 terms. Are there like terms? Okay, we can see, guys, that 4x and 3x are like terms. So what do? We write down the x squared, the 4x plus the 3x. So when we are adding like terms, please, guys, take note of the coefficient of this term. It is positive 4. Take note of the coefficient of this term. It's positive 3. So you are going to say, we are going to keep the variable x because these are like terms. Then we add the coefficients. Remember coefficients, it's 4 here, positive 4, and it's positive 3 here. So what's 4 plus 3? That gives us a positive 7. Are we together? Then that constant term 12 is written there at the end. And we cannot do anything further. It ends right here. Okay? Okay, simple enough, guys. First, outer, inner, last. Aye, guys, it should be easy enough, this thing. I'm sure you guys can see that this is so easy. It's so easy capeasy. All right? So hopefully you guys can see it really is easy capeasy. There's nothing much to it. Okay? Let's look at example 2. Okay? 3y minus 2 into 3y plus 1. So once again, what do we see here? Binomial. How many terms are there in the expression? Which is very important. How many terms are in this expression? Obviously, there is one beautiful term. But what do you notice? Inside each bracket, how many terms do you have inside each bracket? Now, you can pretend as if the brackets are not there. Inside this first bracket, you have how many terms? Inside. You have 3y, you have minus 2. Minus sign separates the 3y from the 2. So therefore, this is 2 terms inside this bracket and also 2 terms inside this bracket. Okay? very importantly. So now we can apply what? Distributive law using S and L. The distributive law here means FOIL. What does FOIL mean? We take the first terms, we multiply them together. We take the first term again, we multiply with the outer terms. We take the inner terms, we multiply them together, and we take the last terms and we multiply together. And as we do this, we are all the way considering what? The multiplication of. So let's look at 3y times 3y. First and foremost, this is positive, this is positive. A positive times a positive gives me a positive. That positive can remain invisible because it's for my first term. Then I move to the number. 3 times 3, okay, is equal to 9. That was beautiful. 9, guys. 9. Then y times y, the letter. We keep the variable, then we add the exponents. Remember, there's a 1 there and there's a 1 there. Don't forget the invisible one. So when we are multiplying, same bases, we keep the base, we add the exponents. So that gives us 9y squared. Okay, beautiful. We are done with the first term. Now we take that, we distribute to positive 1 by multiplication. Again, S and L. The sign is positive here, it's positive here. So what's a positive times a positive? It is positive. Then what is 3 times 1? That gives you 3. Then the letter y is single, so it is combined with the 3. Okay, so we get 3y indeed. Then the inner term, negative 2 times 3y. Negative 2 times 3y. So sign-wise, negative times what? A positive gives me a what, guys? Okay, because we need to consider the sign first. Negative times a positive gives me a beautiful sign that is okay, thank you, let's say for negative. Then the number 2 times 3 gives me what? Number-wise, 2 times 3. Okay, because we're going through each and every sign, the number, the letter. You know, when you care about things, you take them one at a time and you make sure that everything is fine. Okay, 6. Then the y variable, it is alone, so it gets combined with the 6. Then lastly, negative 2 times positive 1. And negative times a positive is a negative. Then what's 2 times 1? It's 2. Then what do we do after that? We check for like terms. Like terms, ukai, like terms, ukai. So we look at 9y squared plus 3y minus 6y minus 2. Do we have like terms? Definitely we do, because the only terms that have the same variable with the very same exponent are these two middle terms. So 9y squared stays the way it was. We go to 3y minus 6y. Remember that when we are adding or subtracting like terms, we keep that variable y because that does not change. But then, please, this is positive 3 minus 6. So what's 3 minus 6? Please, guys, some people, they really butcher it at this stage. They don't add like terms correctly. Guys, use your calculator if you have to. But some of you, you know, you really do the worst here. And I'm like, no, no. And I want to die every time I see such errors. So thank you, negative 3. All right, the coefficient is negative 3. And then that minus 2, obviously negative 2 is just there. And guys, really, we can't do more than that. It ends right there. The future and the destiny of this particular problem ends right there. Okay, that is example 2. So what you must notice is that example 1, okay, did not have a coefficient for the variable for the first term. This one does. Okay, different letter. And also take note that there was a plus sign for both brackets, but this one, there's different signs for the brackets. Okay, let's look at example 3. All right. 2x to the power 3 minus 7y into x to the power 3 minus 2y. Okay. What about this one? So first and foremost, how many terms are in the expression? There's one term. If we look at each individual bracket, inside each bracket, how many terms? There's 2 here, there's 2 there. If you look at each individual term, are these terms like terms? No, they are not. No, they are not. So therefore, that means this needs to be left as it is, and we need to apply what? Distributive law. In other words, FOIL, using S and L. All right? So let us go. Let us do the things. So when we do the things, we start with the F. F stands for first. We take the first and the first. We multiply the first. Start with the sign, then with the number, then with the letter. With the sign, positive times a positive gives us a positive. But we don't have to write the positive sign. Why? Because it is the first term. Then we move on to the amazing number. What's 2 times 1? 2 times 1 is 2. It is 2. We move on to the letter. X cubed times x cubed. What is x cubed times x cubed? We are multiplying same bases. So when we're multiplying same bases, we keep the base, we add the exponent. What's 3 plus 3? The exponent gives us 2x to the power 6. All right? Then, that was first. Now we go on to take the same 2x to the power 3, we distribute it to the negative 2y. We do what? It's the outer terms. First start with the sign, positive and a negative, multiplied gives us a negative. Then move on to the number, the coefficient of this term and that term. We multiply 2 and 2 times 2 gives us 4. Then we move on to the letter. We have x cubed, very different from y. These are different letters. So what do? We simply combine the letters, because multiply combines different letters when they are in the same position. Numerator, if they're in the same position, which is in the numerator, then you simply combine them. X cubed, y. Then we go to our inner term. We take negative 7y, we distribute it to x to the power 3. So negative times a positive gives us a negative. We take the number now, the coefficient, we multiply it with the coefficient of x to the power 3. What's 7 times 1? Gives us a beautiful number, 7. Then y, x to the power 3. We combine the different letters. Does it really matter the order in which I place them? Not at all. It doesn't matter the order. Why doesn't it matter the order? Whether I say y x to the power 3 or x to the power 3 y, why doesn't it matter which order I place my letters? Okay, this goes back to a concept we learned earlier on this year and in grade 8 when we were doing whole numbers, and that is multiplication is commutative, right? But for the sake of my brain and how I know it to be, Hexo, I saw your comment there, don't know why it was filtered. For the sake of my brain and the order of my brain, since this was x to the power 3y, I'm just going to make sure that I write this in that same order, all right? So that my brain can see that, oh, these are like terms, all right? Okay. Your brain should know that these are like terms, even if you had written y x to the power 3, because the order in which you place these letters when they are combined by a multiplication sign doesn't really matter. It still means these are like terms. Okay, then we multiply negative 7y with the last term. So once again, a negative times a negative is a positive. Then we move on to the number. 7 times 2 is 14. And then y times y. We keep the variable y. What do we do to the exponents? We add them. So that gives me y squared. Okay. Surely that wasn't too shabby, hey Nigers? I hope that was really sweet. Okay. Very smooth and cool. Now, we locate like terms. Are there any like terms? Oh, we can see like terms. Okay. Those kids that belong in the same school, that have the same uniform. X to the power 3. Okay, you can see there, Craig and Lesejo. X to the power 3, X to the power 3. Same jersey. Y and Y, same tie. Ha! They are kids from the same school. So kids from the same school, we retain their uniform. That doesn't change. Negative 4 minus 7. What does change is the coefficient, of course. So obviously that's negative 4 minus 7. Please, guys, don't butcher this. I've seen people that say 4 minus 7 and they write negative 3. No. They write negative 3. I don't know why. I don't know, guys. Yo, those people, they kill me every time. So please take note of the sign for each coefficient, right? Yeah. So negative 11. Yes, negative 11. Okay. Yeah, negative 11, same jersey, same tie. X to the power 3y, same uniform. Plus 14y squared. There's nothing else that can be added, guys. You cannot do, I don't know, somehow you want to add these. No, guys. You're like, because there's an x here, there's an x. No, we don't add. These are unlike terms. This we leave like this. All right? Aye, butterfly girls, you mustn't kinda understand. You must understand. Hey, you know, people that kinda do stuff, they kinda get some marks. They kinda perform, and you know. So let's understand fully. If there's something you don't understand, butterfly girl, you must speak out. You know, I don't want people saying I kinda. Aye, you can't kinda. You are. That time for kinda ring has gone and passed. We can't be kinda-ring now. We must know for sure. We must be sure. It's very key to be sure. Okay? Alright. Righty? Rot? Okay. I want to do 3 additional more examples, and then I'm gonna give you your game challenges that you can do. I'm happy you get it now. You must get it. Okay? Yeah, and this is all I'm going to do for today, guys. I'm not gonna go any further. I just wanted to kind of like make sure that we are all together. Don't make me cry. Don't cry for me, Argentina grade 9s, you know, that type of thing. So if we're together, then all is well. All is swell. Okay. I just want to look at another example, example 4. Let us look at this one. Three x to the power 3 plus 4y squared raised to the power 2. All right. All my peeps in here. What do people recommend? What do we do here, my beautiful people? We have 3x to the power 3 plus 4y squared, all raised to the power 2. First and foremost, how many terms do we have here? How many terms do we have? That's where we need to start before we even jump into anything else. Okay, I see you pretties. I see what you're saying there. I used to write it 2 times. Thank you, let's say, for this one term. This is one term. Okay. Then, since we know it's one term, there's something about it though. It is a bracket. You remember BEDMAS? Bracket with a what? An exponent. But inside this bracket, there is a what? there is a plus sign. How many terms are there inside the bracket? There are 2 terms. Very important. Inside the bracket, there are 2 terms. They are separated by a plus sign. So, okay, it is very, very important. Like my dear friend, Gayfei and Prettiness, we need to write this bracket as 3x to the power 3 plus 4y squared into 3x to the power 3 plus 4y squared. Okay, so that we can then see, oh, so this is also what? Thank you, Blessing, for the heart me. This is also a 1 term, right? But it has 2 terms in it. So, so I'm going to use FOIL again. So this is back to distributive law. And we know specifically for these types, FOIL using SNL. All right. Guys, I want to say this from the beginning. There are people that usually do this. They apply the square to the 3, they apply the square to the x, they apply the square to the 4, they apply the square to the y. And then they're like, yes, I got it, woo-hoo! And then they celebrate, eh? There are people that apply the square to the 3, they apply the square to the 3x, they apply the square to the 4, they apply the square to the y. And then they're like, yes, woohoo, I'm right. And then they're like, so completely wrong. Please, let's take note, guys. Whenever there's a plus or a minus sign inside the bracket, separation of 2 terms, an exponent external, we must open however many brackets this exponent tells us to. When there's a plus sign, it's a different story, my good beloved friends. When the question is perhaps like this, or like that. The relationship here between the bases is one of multiplication. Okay, so what you did wrong, this misconception that I just showed you, all right? You see, when the relationship between bases is multiply or it is divide, okay? Remember, inside the bracket, you have 1 term. So when you apply the exponent, you apply this to everything inside the bracket, all right? Because it is 1. But here, inside the bracket, you have 2 terms. So that therefore means, hey, since that is the case, there's a plus sign in between, something that is separating these guys. I need to write the 2 brackets like this. Okay. Yes, the brackets are the same, Kaloku, Craig. They have to be. Why? Because this is 3x cubed plus 4y squared. The whole thing squared. So in other words, 2 of these. That's what this means. 2 of these. 2 of these. So this is one of it, and then there's the other one. 2 of these. Are you together? 2 of these means 3x cubed plus 4y squared, and another 3x cubed plus 4y squared. Okay, so hopefully we are together there. Anyone who is lost, yeah, please guys, please, if we do these things very nicely, then it will be very beneficial to our souls and our maths progress and our maths marks, and we'll be very happy. You know what I mean? I hope you understand what I mean, guys, because this is very important, very, very important. Okay, so if we look at this, then we get me, thank you. DL, distributive law, FOIL, use SNL. So let's go. Let's do it one at a time. This is familiar ground, okay? So the whole point was to say, if you have this type of question squared, let's get it to the familiar ground that we know, all right? Because this is a bracket with a plus separation of terms. So now we can apply the distributive law with the help of FOIL using SNL. Apply the distributive law with the help of FOIL using SNL. Okay, so that it is. That is the FOIL. So first terms, let's go. 3x cubed times 3x cubed. Oh, my beautiful maths gamers, please don't do what people usually do. They say 3 times 3 and they say it is 6. Yo, I don't know. When the mind loses the mind and it's like 3 times 3 is 6. Okanye, oh, when the mind loses the mind and then the x to the power 3 times the x to the power 3 becomes x to the power 9. Yo, then it's like, yo, the death of me. Kill me now. Take me now. I don't want to live anymore. Okay, 3x to the power 3 times 3x to the power 3. Sign, number, letter. Positive times a positive. Positive. Number. 3 times 3, 9. Letter. X to the power 3 times x to the power 3. We keep the base. We add the exponent. So it's 9x to the power 6. Beautiful. I love it. Hexo, you're amazing. Pretties. Awesome as well. Distribute 3x to the power 3 to the outer terms. Okay, 3x to the power 3 times 4y squared. So 3 times 4, positive times a positive first, positive. Number, 3 times 4, 12. X cubed times y squared, combine. Inner terms. Please ask, Craig, you can ask. Ask away. Positive times a positive is a positive. 4 times 3 is 12. X cubed times x times y squared. Remember here we can see x cubed y squared. So what we do is we just arrange it in the order that will make beautiful sense. So that we can see, oh. Then positive times a positive is positive. 4 times 4 is 16, and then y times y squared times y squared is y to the power 4. FOIL applied in its majesty. Okay, FOIL applied in its majesty. Then easily from this point onwards, what we simply do is we add the like terms. Are there any like terms? Oh, indeed. We can see the middle terms, they are like. So that means we keep the variable. Then we add the coefficients. Plus 16y to the power 4. There are no other like terms, so we leave the answer as it is. Okay. Craig, please take note, my beautiful Craig. All right. The reason why we don't do that is because, my beautiful Craig, there is a plus sign. How many terms are inside the bracket? Just forget for a moment about the bracket. How many terms are inside? There are 2 terms inside the bracket, my beautiful Craig, my beautiful maths gamer. So because of that, because these terms are separated by a plus sign, but we can clearly see that there is an exponent on the outside. What we then do, my beautiful Craig, is we do not square the first term and the last term. Because remember, that idea or that concept applies if inside the bracket, my brother, if inside the bracket we had a multiplication sign or a division sign, then we would simply apply the exponent to everything inside this bracket. That's what's important here. Okay. When there's a multiply and a divide, Craig, you could do that. But because our terms are separated by a plus or a minus sign inside the bracket, Craig, open those 2 brackets, my brother. Do the foiling, my brother. S and L all the way, my brother. Like terms all the way, my brother. And then, bam, we arrive at the beautiful expression that we need at the end. Okay. UFW him. I am not Jamaican. Though I can play that game if you want me to. I am not Jamaican. I'm South African. Okay, right, so that's example 4. Okay, I did that example so that my beautiful maths gamers can also appreciate the fact that sometimes in some situations the situation warrants us, it requires us, by virtue of what we have, to basically do or apply that certain approach. Okay, so hopefully everyone is flowing with me. We are flowing nicely, flowing very nicely there. Like everything's fine, like it's pretty might. Okay, yeah. So guys, that is it. Let me now finish you with some game challenge problems, and then I am out so that I can attend to the grade 10s with their beautiful their beautiful geometry grade 10s. I'll be seeing you very soon with the Euclidean geometry grade 10s. We need to pick up where we left off. So let me leave these beautiful grade 9s with some game challenge problems, and then me is going to say bye. I don't wanna be a fool for you. Okay, let's do this. X plus 3. Life's so crazy, but it ain't no lie, baby. Bye. So I'm saying goodbye to the grade 9s very soon. After this game challenge, I'll give them the game challenge problems. Then I'll see you again, guys. Till next time. We'll see each other next time. So the game challenge question says you must simplify a plus 4 into a plus 6. And then 3. What? That's 1, 2, 3. Let's say 4. Life's so crazy, but it ain't no lie. Baby, bye. 5. Yeah, snap. No, don't answer the questions in the comment section, please, guys. And I'm gonna switch off the comment section. I don't want people answering the questions in the comment section. This is game challenges for you to do. You need to write them down. Come on, UFWO. What is this, Mega Mate? Nice singing. You're right, man. You rots. Okay, 7, 8, 9. A cubed minus 2b into a cubed plus 3b. 9. You guys kill me here. These people in the comment section, people rock up here and they're like, dude, it's time for you to do this, it's time for you to do that. Like, I mean, you need to get on with this, you know? What happened, guys, with people asking nicely, people asking nicely? Oh, let me close the bracket there. Thank you so much there, UFW. Nah, I'm not gonna be doing analytical geometry anytime soon. Okay, we'll see. Just chill, please chill. Like really, God. All right. In good time, guys, in good time. But also you must check out my YouTube channel, guys. You guys also must check me out there. You must check out there. The link is in the bio. Okay. The link is in the bio. All right. Okay. I think these game challenge problems are fine. 13 of them. All right. TK, what do you mean? Will you do revision with us? Revision when? TK. TK is saying, will you do revision with us? All right. No, Aramanda, you are missing the point. We are simplifying here. Aramanda is thinking we are solving for x. We're not solving for x here. You see, grade 11 and 12 learners have a serious misconception, which is bothering me like crazy. Okay, because many times I see in my live session, I'll be doing some grade 9 work, and this is obviously, guys, we are simplifying here. So what we are simply doing is when I say I'm simplifying, we are simplifying and we are expanding. In other words, simplify and expand. Now someone will come up here, start solving for x, and I'm like thinking, guys, this is not solve for x, you know, or they will factorize. No, this is not factorization. What are we doing, guys? What are you guys doing? You know? Yeah. So grade 9 learners, I hope you have screenshotted those problems. You do them. Or do you guys want to do them, or maybe we can spend some 15 minutes there. Let me take up some time in 15 minutes. Who wants to come up and you can answer the questions with me, and can lead me along and see what we've learned, these beautiful people. Okay, who has the environment to speak? So we'll invite you up as a guest here. You can request there, guest request. And then we can come and just do it, you know, quick. So that I don't have to, when next time I come here, we don't have to, you know, yeah. Let's do it while it's fresh. It's still burning and boiling. If you say me, then you must, unfortunately, some of you don't have a request. You are ineligible. TK can request, because I can see TK can request, Mkwebu can request, Babeska Forever can request, Aramanda can request. But it has to be people that are in grade 9. Don't want people here that are in higher grades, grade 10, 11, 12, coming and butchering the session for these ones. Okay, you guys just want to do these on your own, so I should just leave you guys, leave you to do it. I can end this live and start up the live for the grade, grade 12, grade 10s. Musanda is like, parents should learn this and teach their children. What do parents say? I'm sure there are parents that are here. You'd be amazed, Musanda. Some parents are doing the most. They ensure that their kids join in the live sessions when I have them. So you can really take your hat off to those parents. They are amazing. They are phenomenal. Some parents have contacted me on the side and they've asked that I assist and help their kids. Oh, the sound. Okay, did you guys hear the sound of music outside? What is this? Why is this thing? Also, that means this person does not have no, guys. Unfortunately, me doesn't want these. Yeah, we need this panel layout. You can request again there. And try and request again. Itumeleng Stumza. You're talking about this one. We did this problem, okay? So 3x cubed plus 4y squared, the whole thing squared. We explained that we actually have to open two brackets, especially because inside the bracket we have two terms. So when we have two terms inside the bracket, it becomes very, very important, okay? Very, very important for us to actually open two brackets. Then you make sure you have plus plus, okay, inside the bracket. Yes, go ahead, go and teach the learners UFW, especially if you have the skill. Why not? All right, why not? Yeah, even me myself, I started this last year. Towards the end of the year with the grade 8s. and the 9s, and I was exclusively just doing grade 8 and 9 alone. 11s and 12s and 10s were not invited. And then what ended up happening is that a channel that I had started very innocently, I thought it was just going to be just a few of those kids would join in, but it exploded. It exploded, and then more learners were joining in, more learners were asking me questions, and more learners were like, let's start a WhatsApp group, and all of that stuff, So that's how I found myself here. Then the YouTube channel as well. I just, like I said, these lessons that I'm doing here, I just take and upload the video lessons that TikTok saves for me. I just go and upload them there in the YouTube channel, and people can go and rewatch the sessions that have been covered here. Then that way, people can always, they can always get an opportunity to get exposed to the content, watch it at their own time, at their own pace, under their own sort of like conditions. So that's good. Me, I'm a happy guy if everybody else is happy. Okay, so guys, I think I'm gonna love and leave you. But with this one, like I said, you open two brackets, because this here says 3x cubed plus 4y squared. Remember, there are two terms inside the bracket. They are separated by a plus sign. We can't square this first term and square the last term when there's a plus sign. We don't do that. We don't distribute the exponent to each respective sign, coefficient, and the variable when there's a plus and a minus sign in between. We need to open, okay? We need to open two brackets, and then we need to FOIL, okay? UFW, you'll never know until you start, okay? So then after that, we can apply FOIL using the distributive law, okay? And then that's it, man. Pretty much is what we've been doing, but just with a little extra incy-bincy spice. Everything nice, everything's good, okay? Yeah, so like I said, UFW, just start it, man. Start it. The thing is, most people, it's just that they know what they need to do, but they don't have they're not impulsive enough to start. I was impulsive enough to start, and I remember at the beginning, I would post a video and like it would have like 2 views, 3, 10, 11. And I'd be like, hey, I don't know if maybe I'm wasting my time, doing this thing. But it's picked up because people genuinely want content that is maths oriented, and people want to come through and they want to join the live lessons. You'll see people will come, and people will come. The minute they see you with your camera phone with the maths happening there, and they can see that what you are doing is authentic, it's genuine, and it really comes from a good place, I think people generally will gravitate towards that and they'll follow through. So yeah, bye prettiness, bye guys. Gonna see you again when I see you. Please do the game challenges. I trust that you'll do it very well. I trust you guys have pretty much got this down. Okay, thank you so much. It was really beautiful. I really loved it. Thank you for the rose as well, UFW. It was beautiful. Yeah, yes, try it out, man. Alexander is as Alexander is saying, try it out, man. Try it out. I mean, even grade 9 learners could start a YouTube channel and push. There's kids, for instance, that are in grade 9 that are so good in maths. So good. I know kids that are on this platform right now that are so good in maths. You see that boy that's saying bye there with the viewer there in the platform. That boy is one of my kids that I teach at school. He's phenomenal in mathematics. Like, he loves maths and he's so good at it. There's also just generally other kids I've met on the platform. There's someone like Lesejo. I don't know if Lesejo is still around here on the platform, but I've met her through this platform, and she is phenomenal in mathematics. She's one of those kids that does so well in maths at school and gets those awards. I know Babe Scaffo Evers' kids there, the one in grade 9 and the one in grade 10, they are also amazing in mathematics. Okay, so yeah, please do screenshot the questions, do them, and then in a future live lesson, we'll definitely look at the corrections for these, okay? So just remember, time to work. I'm taking things one step at a time. You guys can go to my YouTube channel. You can see the foundational lessons I did leading up to this particular lesson. I've done live lessons before. The YouTube link is on my bio. You can check that out, and you can watch the previous videos that I did on live lessons on the same topic, algebraic expressions, starting from the very beginning with a revision of the grade 8 work, and then up to this point where now we are doing binomial by binomial. Remember, coming up, we are going to, in future, do other distribution, addition and subtraction of these, And then also we are going to look at later on factorization, which is another new topic for our grade 9 learners, which they did not do last year, which they'll be doing for the first time. But obviously it has foundational concepts in that learners have done highest common factor, so they're going to see how they apply highest common factor when it comes to factorization and so forth. So yeah, there's a lot to look forward to, and we'll be doing it here in Maths is a Game. Maths is a game, guys. Let's play. We play, we have fun, we enjoy, and we kill it. Yeah, UFW, try it out, my brother. Try it out. You'll see. It's amazing, It's amazing what you can do. And you will come up with some other bright ideas. Trust me. You'll come up with bright ideas. You'll know what to do. You'll know what to do next. And yeah, just take it one day at a time. Okay, guys, I'm going to end this live. I'm going to have the grade 10s now for Euclidean geometry. So hopefully grade 10s are around. I'll be seeing you just shortly. Let me end this live. Bye. Thank you to